In the second half of section 6.3, we're going to look at multiplying and dividing binomial radical expressions. You can use the FOIL method to multiply binomials that have radical expressions. So let's take a look at that looking at this example. We want to multiply 4 plus 2 times the square root of 2 times the quantity 5 plus 4 times the square root of 2. So to ensure that I'm multiplying every piece of each binomial together, I'm going to use the FOIL method. So I'm going to multiply my first terms. 4 times 5 will give me 20. I'm going to multiply my outside terms. 4 times 4 square root of 2. I'm going to multiply the coefficients together, and that'll give me plus 16 square root of 2. Similar thing with my inside terms. 2 times square root of 2 times 5, multiply the coefficients. I get 10 square root of 2. And finally, my last terms. Here I'm going to start by multiplying both of the coefficients. So 2 times 4 will give me 8. And then the square root of 2 times the square root of 2 is just the square root of 2 squared. So from here, I can simplify some stuff. So the square root of 2 squared, basically these terms are just going to cancel each other out. And I'm going to be left with 8 times 2, which is just 16. From there, I'm going to combine like terms. So my regular whole numbers, 20 and 16 will combine. And then learning what we used from the first half of this section, 16 square root of 2 and 10 square root of 2 can combine because they're both by radical 2. So they have the same radical, they can combine together. So my final answer, simplified, would be 13 plus 26 times the square root of 2. The next thing that we're going to look at in this video is multiplying conjugates. So these we kind of talked a little bit about when we did complex numbers. Conjugate pair would look something like this. Square root of A plus square root of B, and its conjugate would be the same thing but just with a minus sign instead of a plus sign. The importance of this is that the product of two radical conjugates is a rational number. So if I multiply two conjugates of radical expressions, it's going to give me like a nice whole number answer. So for example, let's look at 5 minus square root of 7 plus 5 times 5 plus the square root of 7. Same thing as the last problem. I'm going to start by multiplying my first terms. 5 times 5 gives me 25. My outside terms will give me plus 5 square root of 7. My inside terms will give me times negative 5 square root of 7. And finally, my last terms, square root of 7 times the square root of 7 is just it multiplied by itself, so square root of 7 squared. From here, the square root of 7 squared will cancel to just be 7. And from there, my inside terms are going to cancel out because I have 5 plus square root of 7 and minus 5 square root of 7. The inside terms cancel, and I'm just left with my whole numbers, 25 minus 7, which gives me 18. Finally, we're going to talk about if we have a rational or a radical denominator. Sometimes a denominator is a sum or difference involving radicals. If the radical expressions are square roots, you can rationalize the denominator by multiplying the numerator and the denominator by the conjugate of the denominator. So let's take a look at what that means with an example. We want to rewrite 3 times the square root of 2 over square root of 5 minus square root of 2 with a rationalized denominator. So again, what that means for a rationalized denominator is that I don't want to see anything taken to a square root, cube root, anything under a radical sign should not be left in the denominator if I want to simplify it. So using what I know about conjugates, if I want to get the bottom to be a rational number, I'm going to multiply square root of 5 minus the square root of 2 by the square root of 5 plus the square root of 2. And since I don't want the expression to change, I need to multiply the numerator by that expression as well. So I'm going to multiply the top and bottom by these values. From there, at the top, I'm going to distribute 3 times the square root of 2 to both of these terms. That's going to leave me with 3 times the square root of 10 plus 3 times the square root of 2 squared. And then on the bottom, I'm going to FOIL, and I'm going to be left with something like this. Square root of 5 squared plus the square root of 10 minus the square root of 10 minus the square root of 2 squared. So from here, let's break down and simplify. Square root of 2 squared turns into 2. Square root of 5 squared turns into 5. Square root of 2 squared turns into 2. At the top again, 3 times 2 leaves me with 6. And on the bottom, plus and minus the square root of 10 are going to cancel each other out. So in the bottom, I'm left with 5 minus 2, which is 3. So here my denominator is rationalized. I just have one more step to totally simplify this. The 3 is going to simplify that 3 and 6 on top, and I'm left with the square root of 10 plus 2 is my final answer.